Liquid cooling is becoming more predominant in data center GPUs for a number of reasons. As we get generationally further along with GPUs in the data center, they're drawing more and more power and generating more and more heat in order to give us that top line performance increase that we all want so much. It's difficult for air-cooled systems to keep up with the heat dissipation required to run these things. It ultimately leads to potential throttling of the performance of the product. Now, not only the chips in the data centers becoming more power hungry, but the quantity of GPUs that we're putting in data centers is increasing as well. And that puts a lot of tax on the data center infrastructure itself to cool everything down. Liquid cooling offers a unique solution that enables us to keep these chips cold, operating at the performance levels that we all want them to, while actually saving energy. For the B200 specifically, this is the latest generation of data center GPU, and it puts out a lot of heat. In order to run these in the most efficient way, from both a power consumption and performance perspective, liquid cooling offers the capability to keep the chip at the exact temperature level that it needs to run at peak performance, while eliminating the power draw of the fans that you would need to keep it cooled in an air-cooled configuration. Additionally, those fans are some of the highest failure rate components, meaning that liquid cooling actually leads to increased reliability of these GPUs while saving power and enabling them to operate at sort of peak performance levels. Liquid cooling does mean greater reliability, efficiency, and effectiveness for a few reasons. Number one, without so many fans in the chassis, we're drawing significantly less power. In some OEM implementations, we're dropping from 15 kW to 11.5 kW per system. As you scale a data center and build really large deployments of B200s, that adds up. Not only are you saving power, you're not having to cool for that as well. Additionally, the liquid cooling architecture really keeps the chips at the optimal temperature to avoid thermal throttling if you have hotspots. Liquid cooled data centers, sort of do provide this nice facility loop capability to cool water outside in larger, much more efficient systems, reducing the overall PUE of the data center. And that ultimately leads to lower operational costs and higher value for the customers. That said, there are some facilities where air cooling is going to be the only option, and in that case, it is absolutely possible. You're just going to have to be very sort of careful with the thermals and not overloading the facility. We chose to partner with Lenovo and the ThinkSystem GPU machines for a few reasons. First of all, they're engineered extremely well. This is an engineering organization that understands how to build products for longevity and reliability. They also tend to have systems that run with better sort of thermal characteristics in terms of the temperature of inlet water that we've seen. That further enables us to run the data centers slightly warmer, reducing our cooling costs and decreasing our PUE, which allows us to deliver more value to our customers. Additionally, as an organization, Lenovo and their engineering team have helped us work both on the systems with our data center and our cooling vendors to build sort of the optimal install that helps us deliver the right combination of cost-effective, quality compute cycles to our end users while really keeping our budget in mind. The Corvex B200 installation, because it's liquid cooled, does deliver the trifecta of performance, reliability, and lower cost because of the liquid cooling. Liquid cooling eliminates fans. It allows us to operate these chips exactly where they need to be thermally on a lower amount of energy with higher reliability because some of those high failure rate parts are no longer in our systems. What we're seeing in future roadmaps of GPU vendors like NVIDIA is that the thermal output of individual GPUs, racks, and large-scale data centers is going to continue to increase. We're going to be moving from 100 kW per rack well beyond 500 over the upcoming years. Liquid cooling really is the future of AI. As we look at our 100 kilowatt racks today, and then look forward at the roadmaps of the major OEMs like NVIDIA, we see on the horizon multi-hundred kilowatt and beyond racks. In these types of configurations, it's going to become more and more challenging for any air-cooled variants to perform reliably. Therefore, as we move down the road in 26, 27, and beyond, it wouldn't surprise me at all if air-cooled becomes a variant that is only used in environments that can't support liquid cooling with decreased density and decreased performance as a trade-off for using that sort of mode of cooling. Here at Corvex, we love this stuff. If you're interested in learning more, call one of our data center engineers or just stay tuned for the next video.